This is the first part of our Calculus 2 Power Series lesson. In this lesson, we're going to look at a power series centered at x equals a. Okay, so here's our power series. It is a summation from n equals 0 to infinity of some coefficient c sub n times x minus a raised to the n. This is A. A is where our series is centered, and this n is what makes it a power series. Each term is unique based on its coefficient. So let's expand this, moving this here, and this would equal, when n equals 0, we would have c sub 0, and x minus a is raised to the 0, so that's 1, plus c sub 1 times x minus a raised to the 1 plus c sub 2 times x minus a raised to the 2, and this continues on so that we have each term is c to the n times x minus a raised to the n and off to infinity. Okay, now we're going to look at geometric series. And if you remember from the past when we looked at a geometric series it's a summation. We're having it n goes from 0 to infinity of a times r to the n, and this is where r is our geometric ratio. So this is the geometric series that we know. Now let's look at a geometric power series. Here I'm going to go from n is equal to 0 to infinity times x to the n. Now this is a geometric power series where a is 1, so our a is 1, and then our geometric ratio is x, and this is raised to the n. And this is going to be equal to 1 plus x squared, and it's going to keep on going. This is, of course, there are infinite terms, plus x to the n plus, and this is going to keep on going, and this goes off, of course, to infinity. So here's let's move this, oops, so we can move this one over, make a little bit of room here. Okay, so there's our geometric power series. Recall with the geometric series, I'm going to move this over, if our geometric ratio, which is r, is, if its absolute value is less than 1, then our geometric series converges to the ratio a over 1 minus r. So what does it mean for this geometric series that I have here? Here we see that x is our geometric ratio. So that means that when the x is less than 1, then our sum from n equals 0 to infinity of x to the n is equal to the ratio, the same that we have above here, a divided by 1 minus r. And in this particular case, let's put this over on the side, in this case, a is 1, and the geometric ratio r is x in this particular geometric ratio. So in the numerator we have our a, which is 1, and then we have 1 minus x. So going back to our value of x here, where the absolute value of x is less than 1, what that means that whenever x is between -1 and +1, or in interval notation, we would say -1 to 1. So whenever x is between -1 and 1, our geometric power series converges to the function 1 over 1 minus x. So in this case, we were able to determine for what values of x does this series converge, and what function this series converges to. The values of x for which this series converges are from -1 to 1, and the function that this series converges to is 1 over 1 minus x. Okay, now we're going to look at another geometric series. This time we're going to center at 2. So we're going to do a summation from 0 to infinity, and here's our coefficient. This is an alternating series, so I have -1 to the n, and in the denominator we'll have 2 to the n. And that's the coefficient, that first part, and here's x minus, and here's the center, -2, and this is raised to the n. So here we go. This is our geometric series centered at 2, and I'm going to move this over a little bit. And so what is this? The first term, if you look at this, n is 0, so -1 to the 0 is 1, and 2 to the 0 is 1, so this is a 1. And then we have x minus 2 raised to the 0, which is also 1. So the very first term will be 1 minus, now I'm saying minus because when n is now going to be equal to 1, that's the next term, and -1 to the 1 is -1, so we have a negative sign here, and then 2 to the 1 is 2, so this becomes 1/2, so 1 minus 1/2 times x minus 2 raised to the 1, so we have times x minus 2, plus, and I'm going to write the next term underneath because it's a little bit tight here. Our next term is going to be n equals 2. See, let's mark this. This was our first term right here, was when n equals 0. And our next term, which is right here, is when n equals 1. And now we're going to have a term when n is equal to 2. When n equals 2, our -1 squared is a positive 1, and then 2 to the 2 is going to be 4. So we have 1/4 times x minus 2 squared. And you can watch the pattern now because the next term will be negative, and it'll be 1/8, because we have 2 to the 3 in the denominator, times x minus 2 cubed. And this is going to continue going, and each term will be -1 to whatever n is, divided by 2 to the n, times x minus 2 to the n, and this will continue on infinitely. Let's take this one, move this up a little bit. Let's get some of this stuff moved up so we can fit this. Move the 1 up. These are separating on me a little bit. And we'll move this up. There we go, right in the center. So there we have it. This is the beginning of an expansion of a geometric series centered at x equal 2. So on our next slide, let's take this geometric series centered at 2 and determine where it converges, for what values of x it converges, and to what function does it converge to. And we'll do that on our next slide. Okay, so here we're looking at our geometric series, and when we look at this, we want this, let's move this up here, we want it to be of the form that it is, let's see, the sum from n equals 0 to infinity of a times our geometric ratio r to the n. And what we know is that when the absolute value of r is less than 1, then this series will converge to a over 1 minus r. So that's what we want to use. So let's take this and let's move this over here. Okay. So I'm going to change color to blue. And so in this particular case, a, if you look at this, a is actually equal to 1, and r is equal to a negative 1/2 times x minus 2. Because that entire expression, negative 1/2 times x minus 2, is raised to the n. So that's our r. So we want to know, when is the absolute value of r going to equal 1? So let's set that up. So x minus 2 over a negative 2, that's our r. When is the absolute value of this going to be less than 1? So if we lift the absolute value, we end up with negative 1. When is negative 1 going to be less than? And what I'm going to do is, let's multiply the top and the bottom by a negative, making the numerator 2 minus x, and the denominator just 2. And this is less than 1. And if I multiply all sides by 2, I have negative 2 is less than 2 minus x, which is less than 2. And now I'm going to subtract 2 from all sides, so I end up with negative 4 is less than a negative x, which is less than 0. And now I'm going to multiply everything by a negative, which changes the direction of my inequality, so I end up with x is between 0 and 4. So this is my interval of convergence right here, from 0 to 4. So let's move that up here. We've discovered our interval of convergence. That's important. And so we'll put a box around our interval of convergence. And our next question that we must answer for this geometric series, power series, is what function does our power series converge to at this interval? So I'm going to change my color, and I'm back to black. And so it's going to converge to the ratio of a over 1 minus r. Well, a is 1, and r is this expression right here. So let's write that down. So it's going to converge to some function, a, which is 1, over 1 minus r, and r is x minus 2 over a negative 2, and I'm going to take that negative 2 and factor that out, making this positive. So let's simplify this by multiplying the numerator and denominator by 2, so I end up with 2 over 2 plus x minus 2, and of course the 2's in the denominator cancel out, and this becomes 2 over x. So our series will converge to the function y equals 2 over x for the interval of convergence 0 to 4.